The chapter is Quadrilaterals for standard 9. Now here it is given ABCD is a isosceles trapezium. In an isosceles trapezium, one pair of sides are parallel and the non-parallel sides are equal. Just for a trapezium, one pair of sides are parallel. If it is isosceles, you have one more condition. The non-parallel sides, that is AD, is equal to BC. Now this ABCD is an isosceles trapezium. You have to prove angle A is equal to angle B, angle D equal to angle C, and then triangle ABC is equal to triangle BAD, and also the diagonals are equal. AC is equal to BD. So here we will draw one construction, that is we will draw CE parallel to AD. From here we will just draw one line parallel to AD and we will extend this AB here. So now we can say ADCE is a parallelogram because already AB is parallel to CD is given. Now we are drawing a line CE parallel to AD. Therefore ADCE is a parallelogram. So let's start with that. So construction, draw CE parallel to AD. So now AE is parallel to DC is given, and AD is parallel to CE by construction. Therefore ADCE is a parallelogram. Now since this is a parallelogram, these two sides, these two angles are supplementary. Adjacent angles in a parallelogram are supplementary. Otherwise AD is parallel to CE and these form co-interior angles. So angle 2 plus angle phi is equal to 180. We are given the names of these angles. 1, this is 1, 2, and this angle as 3, this is 4, this is 5, and this as 6. So angle 2 is equal to angle 2 plus angle phi equal to 180. The reason is AD is parallel to CE and co-interior angles. Now angle 3 plus angle 4, they form a linear pair. So you can write angle 3 plus angle 4 is equal to 180. Now these two, ADCE is a parallelogram, therefore AD is equal to CE. So we will write AD is equal to CE because ADCE is a parallelogram. Now we already know AD is equal to BC. It's given. Therefore BC is equal to CE. So BC is equal to CE. Therefore 2 is equal to angle 2 is equal to angle 3. Therefore angle 2 is equal to angle 3. So here, so we'll give this as 1, 2 and 3. So from 1, 2 and 3, 1, 2 and 3, we can say 2 plus 5 is 180, 3 plus 4 is 180. So we can equate 2 plus 5 equal to 3 plus 4, and 2 and 3 are equal. So 2 plus 5 is equal to angle 3 plus 4, and 2 and 3 are equal. So from that you can write angle 5 equal to angle 4. So we have proved angle A equal to angle B. Now similarly we can write angle 1 plus angle 5 is equal to 180 because AB and CD are parallel, and angle 4 plus angle 6 is equal to 180. So from this we will get, we know angle 5 and is equal to angle 4. From that you will get angle 1 is equal to angle 6. So we have proved angle D is equal to angle C. Now you can prove now you have to prove ABC, and so consider the triangles ABC and triangle BAD. So ABC, now we can say BC is equal to AD. Then we can say angle 4 is equal to angle 5, and AB is common. So we will write this down as AB is equal to AB common. This is side. Then we have angle 5 equal to angle 4 is angle A, that is angle proven. Now we have this, and then we have AD, ABC. So we will write BC. Here we have to write ABC is what we are considering. So angle 4 is equal to angle 5. And then we have BC is equal to AD. BC is equal to AD is given. Therefore, triangle ABC is congruent to ABC is congruent to BAD by SAS. From this we can say AC is equal to BD CP CT, congruent parts of congruent triangles. So we have proved this also. Here in this figure, it is given PQRS is a rhombus and SRT is 152, and now we have to prove, you have to find out all the angles X, Y and Z. So now this is 152. Now this angle 1 and 152 form a linear pair. Therefore angle 1 is equal to 180 minus 152. The reason is linear pair, that is equal to 28 degrees. Now if you see, this is a rhombus is given, that means SR and SP are equal. Therefore you can say angle Z is equal to angle 1. So angle 1 is equal to Z, that is equal to 28 degrees. The reason is SR is equal to PS. PQRS is a rhombus. Now we got Z. Now in a rhombus we know the diagonals bisected right angles. Therefore angle Y is equal to 90 degrees. Reason, diagonals bisected right angles. So now we have to find the value of X. Now if you see this X and this angle, let's say this is 2. So angle 2 is equal to X alternate angles, alternate interior angles. Now angle 2 can be found. Now we already know angle 1 is 28 and y is 90. Therefore angle 2 is equal to 180 minus angle sum property 90 plus 28. So 180 minus 118, that is equal to 62 degrees. So we got angle 2 as 62 degrees. Therefore angle x is equal to 62 degrees. So y is equal to 90 and angle z is equal to 28. In this figure, ABCD is a rectangle and ECD is 146. Now we have to find the value of angle AOB. So here we are using all the properties of the rhombus. Here the properties of rectangle, that is the diagonals are equal and they bisect each other. So here 146. So let's name this as angle 1. So angle 1 is equal to 180 minus 146 because it's a linear pair, that is equal to 34. So angle 1 is equal to 34. Now since the diagonals are equal and bisect each other, you can say OC is equal to OD. Reason is diagonals are equal and bisect each other. So therefore, since OD is equal to OC, we can say therefore angle 1 is equal to angle 2. Isosceles angle property. So we know angle 1 and angle 2 are 34 each. Therefore angle 3 is equal to, therefore angle 3 is equal to 180 minus angle 1 plus angle 2. So that is equal to 180 minus 34 plus 34. 180 minus 68. So it is 112. So now this angle AOB is equal to angle 3 because vertically opposite angles is equal to 112 degrees.